Hello everyone, welcome back to Level Up NJ. So in today's video, we have discussed about another problem, rotate array. So let's get into it. So here is the problem. So let's first understand the description and then we will move forward the naive approach, and after that we will see the optimal one. Okay, so let's understand the description. So given an array, integer array nums, rotate the array to the right by key steps where k is non-negative. So here k is always be positive and we have to rotate the array right by k steps. Okay, this is the description of the problem. Now let's understand the example cases, and based on that we will think about the solution. So this is, we have an array nums uh, contains 1, 2, 3, 4, 5, 6, 7 and k is equal to 3. So based on 3, uh, index 3, we have to rotate the array. Okay, so here the index 3 is 4, and based on that the rest of the elements will be rotated on the right side of the array. So first step to the right. So 7. So first they pick 7 and they rotate, and the second step they do the same, the last element, and they just shift it right. And third one is they pick up the last element, fifth, and they shift it right. Okay, this is actually happening, and after that we will get our final array. This example 2 is the same. We have an minus 1, 100, 399 and k is equal to 2. So the index 2, rest of the element will be shifted on the right of the array. So the first step to the right, yeah, they picked, just understand, they pick the last element and they rotate. And the second step, they do the same, pick the last element and they do the same thing. Okay, so let's understand the constraints. So nums don't length till less than, so nums don't length less than equal to 10 to the power 5, and the every element will be, between these two cases, and k, based on that we have to create the array is less than equal to 10 to the power 5. So this is the question. So now let's first understand how do we think about this question. So we have an array, and every step we pick the last element and then just move it to the right of the array. So first thing, we have an original array, and based on the k, first we do 7 is the last element, we move forward, then we shifted the element, and 6 will be the last element, then will be shifted, then 5 will be the last element, and then it will be shifted. Okay, so this is all happen for getting the output of this question. Okay. So now let's think about the first naive and brute force solution. What actually can we do? So as per the question example we have seen, this approach we will take two nested for loop. So the first for loop will run till k and will responsible to take the last element and put it on the first or zeroth index of the array. Okay, that's actually happening here. And then the second loop will responsible to shift the elements. As we see the question and the examples here, first choose the last element, then shifted the element. Okay, and we will do the same. So we will take two for loop. First we'll run till k, that responsible for just holding the last element, and just make it and put it on zeroth index, and then the second element will change and shift the element. Okay, so this is one of the brute force approach we can do. But so the time complexity of this naive approach will be like we will using two loop, and the first will run till k, and the second thing is will shift the all n elements. So the time complexity of this problem will be o n into k. Okay, so which is not asking, let's move forward to the optimal solution. So for optimization of this problem, we think about that. This is the, we have array and we have to shift all the elements after the kth index. Okay, now let's think about that. So what we can do? So we can first we can reverse the complete array, and then partially we will reverse the array till k and rest of the a minus k. So we will use the reversal technique to solve this problem. So first we will reverse complete array, and then we will reverse till k minus 1, and then the rest of the n minus k. Okay, so this will be our approach to solve this problem, which is optimal. And the time complexity of this problem will be like linear and constant space complexity. So let's try to do that, and then we will explain. Okay, so first we will use two pointer start and end to reverse the array. So yeah, let's do. So int n is equal to num dot uh, we will ensure, like, now let's understand this line. So as per constraint, in some cases k will be more than the size of the length. So for example, k is equal to 10 and n is equal to 7. So the rotation of k time will be equal to the rotation of k modulo n. So for that, we will use k percentile n, because in some cases k will be more than the size of the array. Now let's create two pointer. First one is start. Basically the pointer will help us to change and reverse the array. Let us start from 0 and then the second, which will n minus 1, and we will create a while loop. Start always be less than end, and then just change the positions, and temp will hold start nums, nums start, and then uh, nums will hold here and will hold temp. This is the basic thing we are doing in order to reverse the array, and then we will move forward, both the pointer start plus plus and minus minus. So the first value will help to reverse the whole complete array, and then as we discussed in second step, we will reverse the array till k minus 1. So let's do that. So first, change the pointer. So start will be pointing 0 and k minus 1. Then we will do the same thing. Now, as we discussed, we will try to do this question three steps. First, we reverse the complete array, then we will reverse till k minus 1, and then rest of the elements of the array. So now let's change the pointer. So here start is equal to k, and 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 will go till k n minus 1 at, at the end of till array. Then we will use the same while loop. It's done, everything's fine. Okay, so yeah, let's check it. Accept it, and then try to submit. Very interesting question, by the way. Yeah, it's done. And the complexity of this question will be like linear time complexity, and we will the space complexity, constant, because we didn't use any kind of data structure. So here is a so there are at least three different ways to solve this question. So in this video, I've discussed two kind of solution of this problem. So if you know the third one, just comment below and let me know about your solution. So if you found this video helpful, just like, share, and subscribe my YouTube channel and be a part of this journey. So